This is the third lesson about RobotStudio, and this time I'm going to show you how to do text programming, and that is called Rapid in RobotStudio. So let's just make the same station as last time. So this one. Okay, we have a robot, and let's put the welding torch on it. And connect it. Yes, at the position. And now we're going to also import one geometry that I have made for this, and we do that here with import geometry. And I just have to go here to the, and so we have all supported files here selected now, and I'm not sure why, but here on the virtual computer I can't import step files. On my physical computer it works, but on this one it doesn't. I don't know why, so that's why I made this .sat file, and I will provide this for you also, so you can import it. And let's adjust the position, set position, and I have already the coordinates for this. 500, 0, and 90, and apply. Okay, and yeah, now we have the station ready. And now the first thing that we're going to do is create some elements in this same as we did before in the station. So we can go here to paths, and the first thing that we are going to do now is create a new work object on this plate. And we do that here. We go to other, create work object. We can put the name here, training piece, or whatever you want to call it, and then frame by points, 3 points, and selection filter, and then click here on the first point, and now you can click on the points. And accept and create, and we have a work object here. So let's take this out, and let's attach this work object to this piece. And so we say attach and training piece. Update the position, no. So now if we move this object, also the work object is going to move. And now we can make some paths, and we're going to do them with AutoPath. So let's go to AutoPath, and let's first make this one here. So blue arrow pointing down, and start this. We can all leave linear, but we should do this depart and approach. We can put 100 millimeters. And so always when you are making some kind of action, you should always make this kind of approach, because the robot will come here with fast speed and with joint movement, and then it takes a linear movement down to the beginning of the actual path. So you should always do this short linear movement to just to make sure it approaches the way you want it to approach. And we can create this one. Oh, actually I forgot to modify the creation parameters. Let's do that now. So we can leave that, but let's put this zone 5. So it will pretty much follow the geometry, but it will take a small radiuses here so it doesn't stop in between. And okay, now let's take next this circle, and here I can show you a little bit more here with the start offset. So let's put start offset 150 for example, and with the end offset, if we put minus 100 for example, you can see that it moves to the, so the official end is here, but if you put end offset minus, it goes back to where it started, or it goes back to the beginning of the path. So if you want, for some reason, make it like that you start here in the beginning, you can do that. And this is a circle, so we can take circular approximation, and then more, and also here let's put 100 and create. And now same for this one. And let's leave that, but with still again here approach and depart and create. Okay, we have some paths. We can close the auto path, and now okay, here are our targets. Let's rename them first. So you can just, so either click and wait and click again, or you can right click and say rename, and let's say P for path or process and line, and this one, so this is now P ellipse and P circle. And here in P line, let's change the zone first. So select everything and edit instruction and change the zone to 5 and apply. And next thing we have to do is put this initial movement to joint. So select that, or actually we can just open all of these and select all of the first ones and select joint here and apply and close. So let's see how it goes. So we have some errors here, as you can see. So these red ones are not reachable. We definitely have to fix those. And then these yellow ones have some kind of configuration problems. But let's try to run this line since it's the easiest one. Yeah, so it has a problem. So what we can do first is right click, auto configuration, all move instructions. So now it's going to find the most optimal configurations for this path, and can select the initial configuration, first or second. Here it's a bit annoying, you can't rotate your view when you are doing this, so let's try it first. Apply. Okay, it looks quite okay, but it's a bit awkward positioning. Maybe it would be better if we rotate these points a little bit, because now it's pointing that way, but if the X, so if I zoom in, so now X is pointing that way, but if X would be pointing downwards, it would be better. So we can go to targets and so this is this one. And if we say now modify target, rotate local reference, and rotate around Z, and is it 90? Let's try 90. Yep, 90 is okay. And let's select also these other ones and rotate those and close. And let's see. So now we have to, because we moved them manually, we have to configure it again. So let's first adjust the view, so then it's a bit easier when it's asking us for initial configuration. Right click, auto configuration, all move instructions, and initial configuration. What's the difference here? I don't know. I think this one looks maybe best. Yeah, let's try this one. Apply. Yeah, this looks good now. And now next, let's go to circle. I'm leaving the hard one for the end. So let's run auto configuration on the circle. Okay, it runs. Move along path. Now it's going to go a bit slower so we can see what's happening. Auto configuration always goes really fast. I think we can also change all of this to that they will all have the same orientation, so it's not swinging around. So let's see which one. If we say see roboted target, okay, 50 is the first one, and 110 is the last one. No, actually, it would be better if I'm using view tool at target. And let's turn this off, and this one, this away. And so target 50. Let's see which one, if there's any good ones already. Oh, actually they are pretty okay already, only that one target 100 is different, or target 90 actually. So let's just copy this one, target 80, copy orientation, target 90, apply orientation, and circle, move along path. Yeah, and that looks good. And now here in ellipse we have a bit more complicated. Oh, actually, yeah, I think I made it with linear. So I'm going to delete ellipse and try it again. So path, auto path. Oh, actually I still have to delete those targets. So 120 is the first one, and all the way to the end, delete those. And now so circular interpolation and arc and approach 100, create and close. Okay, so I have to rename this again. The ellipse. First one goes to joint, exit instruction, motion type joint, apply and close. And yeah, as you can see, they are not reachable. Most likely they are. The problem is that the robot would have to be in some strange position. So yeah, like it's pointing this way. We are going to have to make it like that, same as what we did here with these targets on the line, so that the x-axis is pointing downwards. So these two, it can reach, yeah, they are down, and so they're pointing downwards. But if we just try to copy the orientation of these line ones, so copy orientation, and let's select these last ones and apply orientation. Let's see how, okay, it looks like it should work. So move around that. Okay, that works. So now the first thing we're going to do is we're going to synchronize these things that we have done now to Rapid, because there are two different work environments: station, where we are now, and Rapid, where we're going to, what we're going to do now next, which is text programming. So here we have this button, synchronize, and we can say synchronize to Rapid here, and everything, we should have everything selected now here, what we want to synchronize, and okay. So now we can go to Rapid, and here open Rapid, this trob1, module 1, and double click module, and now you can see here, maybe I should have told you to go see how Rapid looks before synchronization, but basically what you would see otherwise is there's just nothing here. There's just saying this module 1 and process main, and that's it, but none of this and none of this. But before I go to explain this, let's do one more thing. We're going to create a few signals that we can use in programming, so different inputs and outputs. And how we do that is go here to configuration and EO system, and be careful, or not careful but aware, this is not the correct place. I always forget and I try to do it here. So if you go here, this is a different thing. So you have to go here to configuration and input output system, and now go here to signal and right click anywhere, doesn't matter where, and say new signal. And now here you can first give a name, and let's make outputs first. So it's going to be digital output, so I'm going to start the name with DO, and now I'm just going to say button 1, type of signal, digital output, assigned to device, nothing, level that you don't have a chance to select here actually, and then access level you should set this to all. Actually for digital outputs by default is all. It's more important than inputs, because if it's read only, then you can't change it manually by clicking on it. Only the program can change it. But I'll demonstrate that in a moment when we finish all of this. And now okay, so here it says our virtual controller isn't going to work until we restart it, because if you remember when I was saying before, virtual controller is a simulation of a real controller, and right now what we did is we plugged some sensor, or actually right now a button, into that controller, and it needs to be restarted if you want to if you want the system to be able to detect this output. So let's just say okay, and don't restart right now because we have to create more of them. And I'm going to just create a few of these buttons, just so we have a little bit more options when we are then programming. so we can make a little bit more complicated systems to demonstrate some things. New signal, digital output, and all, and okay, yes. And now let's make digital input. Oh, actually, this is, I made it wrong. The buttons are inputs. So now let's make digital output light 1 and say this is digital output and all and okay. And now we have to change this actually. So let's say go here and edit, and this is input, and change here digital input, and this is all already okay. And next, edit signal, input, okay, edit input, and okay, yes. And let's make another light. So new signal, digital output light 2, so digital output and all and okay. And that is, I think, enough. So what we can do now is restart the controller, and yeah, warm restart, okay. And now if you go here to simulation, as soon as this is restarted, yeah, now it works. You have here input output simulator. So if you select that, here you have what system you are working in. So we are working with this robot. So the signals that we have created are now part of the robot. And so if we can have device here, and then panel is none, and now we have all these buttons that we have created. But if you want, if you have some more complicated things, you can also go to user list and edit list and new list, and now you can add these that we have created to this list. And okay, so now we have this list here and this inputs and outputs here. So if you would have some different groups of signals, you could make different lists, so you don't have a big mess here. And now actually, since we're here, let's enable the TCP trace and back to Rapid. And so now here you have two different tabs, so you can close this input output and this configuration, and now we have the Rapid. First thing that we can do is delete this green text. So the if a line has exclamation point in the beginning of it or in front of the text, you can, that means that it's a comment, and the program, when it's running, it won't read that line. So also, if I just want to say, if I want to skip this line for some reason, I can just go here anywhere in front of it and put an exclamation point, and as you can see, it turned green, so it means now it's a comment and it won't read it. And one more thing, here all these blank spaces, so here or like anywhere, blank spaces are not read. So it's not like in, for example, in Python, you have these different levels of indentation. Here that doesn't do anything. You have it just to make it easier to read, but like even if I do this or this, it doesn't make any difference. It still reads it normally, but it's nice to have just to make it read easier. So let's delete these green ones because they are just now instructions to about how to build this. And the first thing here that we see, these are the targets that we have created. So const, it means constant. Rob target is the type of constant, so robot target, and then you have the name of the target and then the coordinates and configurations of it. And always when you are putting in constants, you have to use this sign. So if you put only like this won't work, because this is Boolean sign. I will show that actually later. So when you are defining something, you have to use this colon and equal sign. So here we have a bunch of these targets, and then we have processes. So a process is basically a sub-program. So process main is the one that the robot runs. So if I run the program right now, nothing is going to happen because there is nothing in process main. So you see, it's then you have there is the name of the program or the process, and then there's blank. So even though we have these processes here, nothing happens if this is blank. But if we then write something here, so we can say p line, and here when you start writing, it always gives you suggestions of what you can use here to make it faster. So when you see this, you can either double click it or you can press tab and it will auto complete it for you. And now, so this is the process that we want to run, and then how we have to finish the line is with the semicolon. So all of these have to have the semicolons. This process line, for example, and end process don't, but all of these other the commands, they have to have semicolons in the end. And if we go here to view now and press here, it should run the line, and you can see now it jumped back here. So but we still want to watch what happens, and how we solve that is right click here on the this bottom row of the tabs and say new vertical tab group. So now we see both at the same time, but so you have to click here. If you click on this top one, you won't get it, so you have to click here on this bottom one. And now if I run, we can see it, and we can also see here what is happening in the program. And here we have these two different pointers. So this yellow arrow is showing where the program is at that moment. So because the program is reading these lines, so it goes in order, and this arrow is showing where it is. And then this icon is showing where the robot is. So you have to be a bit aware of this. The program isn't always at the same place as where the robot is. But again, this is a little bit, we're going to talk about this a little bit later. I'm going to show you what that means, but just keep that in mind. And there's one thing here. Actually I can't show it now because we don't have enough code, but if you right click and here you have follow program pointer, so now it's deselected, but oh, actually I can do it like this. So now it's not selected. I am not following the program pointer and nothing happens. But if I select this, follow program pointer, and now start it, you can see your view is going to move wherever the program pointer is. And that is useful if you have, now it's such a short program, it doesn't make any difference, but when you have many lines, you can have hundreds of lines. This is very useful because the program pointer is jumping around depending on what the commands are, and if you want to follow it, this is really useful, follow program pointer. But it can be also annoying if you don't want to follow it, so it's good you can use it or not. Now let's make a new process, and I like to have my main program all the way in the end so it's not lost somewhere in between. So I'll copy that down, and sometimes when you see when you copy this indentation, it can give you a little bit of a trouble, but I think it's, yeah, you'll manage. And let's delete this P line, and now copy this all of this code from the ellipse and put it here. And a little bit about what this code here means. So first one here, I think you can guess what it is. So move is just move command, and then you have J, L, or C. So joint, linear, or circular. And for joint and linear you have only 1 point, but for circular you have here 2 points, because this one, the first one, is a point that is somewhere on this circle or arc, and then the second one is the end of the arc, and then this previous one is the beginning. And actually, if you want to have more explanations about what each of these things are, here is very useful thing. So you can go to File and Help, and you have repeat instructions, function, and data types. And so it will open Help, and if you go to index and just write, for example, move C, and open it, now you have here an explanation of how to use move C. So for example, here what I was saying, so this is the bracket, and so this is the start point, which is the point, the previous point. Where are we now? So here, so this point where we started, so this move instruction comes to the beginning of this circle, and then you have the next one, which is this one, and then the end of the arc, which is this one. So, and here you have a lot of explanation of what are some limitations and what kind of options you have. So here you have what are the optional options, and then here in the end you have always some kind of extra information if you want to learn something that is connected with this but is something else. It's sometimes useful. So always, if you don't know something, go here to the repeat manual, it's really useful. And then if we go forward here, so we have the target, and then we have the speed. So if it starts with V, it's for velocity, then zone 5, then we have what tool we are using, and then we have what work object we are working in. And this is pretty useful also because you can just change the work object here, and the program is going to go, so it's going to keep the same numbers of the point of the target, so these numbers here, but it's just only going to position it in a different work object. So for example, if you are moving something from one palette to another palette, you only have to save the location on the first palette, for example, but then for the when you want to put it to the second palette, all you do is change the work object here, and then it's going to put it in the same position as it was on the first palette on the second palette. So this is quite a nice time saver. And now here you can change. It's very easy to change here. For example, this first move is it goes there for wherever it is, so we can say it can be maximum speed, so Vmax. And you can see if your code is correct. So if you have this kind of command as speed, for example, if it goes to this light blue color, that means that it's okay, or so the syntax is okay. There might be something else wrong if in your process, but the syntax is okay, so that the program is going to be able to execute this. So now we have this, so this first command, and let's put a new command here so that the robot is going to go here to the beginning of the ellipse, and then it's going to wait for us to press a button here, and it won't start until we press the button. And how we do that, we have a wait command, and now you can see here it gives us the options. So we have digital input, so we say wait digital input, so wait di, and then so you put space, and then if you go here with the mouse, it shows you what are your options. So here we have all the different things that you can put after this wait digital input, and if they are in this square parentheses, this means these are optional, but these ones here, these are mandatory. So we have to say what is the name of the signal, and then we have to say what value is the robot waiting for, because this can be either 1 or 0. So we have to say, is it waiting for it to be 0 or 1? So we say D, and it gives us already, so just press tab, and now we say wait for it to be value 1. And let's try this. So let's just play. It comes here, and now it's waiting for the button, and now it makes the round around. And now I'm going to turn the button off, because so the next time it will not automatically start. And we can actually also say in the beginning of this process, the program should always turn the button off. So, and we can say that by this command reset. So reset resets the inputs or outputs to its default value, and the default value for all of this inputs and outputs are 0 right now, but you can also change it so it's by default 1. So actually, so reset and the button. Actually, I guess we can only reset inputs, not outputs. Or we can only reset outputs, not inputs. So this is also one reason why this is useful. It shows you what is possible. And right now I wanted to reset input, but apparently I can't, because technically inputs are not, so in real life they are not controlled by the robot. It's whatever comes in. so the robot can't control it. So yeah, let's delete this, and we just have to do it manually. But we can now here in the end add that we want to, when the process finishes, we want this light to turn on. So we know, for example, if we are in a workshop, when the light turns on, the process has finished. And how we do that is we just say set and digital output light 1, and that's it. So if we say only set, then we don't have to put a number, because so reset puts it to 0, set puts it to 1, unless you have it reversed, but don't pay attention to that right away. Right now you can just consider reset goes to 0, set goes to 1. So let's now try. Okay, it's already there, so waiting for the button. Now it goes around and the light comes on. And maybe you notice now the light came on a little bit earlier. So let's try again and pay attention to where the robot is and where the light is, or when the light turns on. And light went on. So when the robot was here, the light went on already. So that's because, like I was saying before, the robot and this program pointer aren't always synchronized. So the robot was still making a movement, but the program pointer already jumped forward and turned the light on. So there is a way how to avoid it, but we'll come to that later. And the next thing I would like to show you here is the wait command. Oh, actually we have wait command, but I can show you a different wait command. So wait time, we have it here. So if I put one more T, it gives me time. Oh. Wait time, and here now you can see we have optional is this one in position, but then what we have to put is number for time. So we can say 5 seconds and finish this, and then let's say after that we turn the light off. So reset digital output light, and let's run it. Button. So now there's the light came on, and now it should wait 5 seconds, and now light went off. And one more thing here, if you want to set your digital output to a specific value, so you want to be sure that it will go to 0 or that it's going to go to 1. So you can say set digital output, and now say light, and if you say set, so if you just say set, it will always go to 1. But if you say set digital output, now you have to give it the value of what you want it to go to. So we say 1 here, and we finish and run again. So we have the button pressed already. Oh, actually I forgot one thing. Wait time, and let's just say 3 seconds down, so we don't have to wait so long, and let's restart. So light came on, now it's waiting for these 5 seconds. Now light went off, waiting for 3 seconds, and light went on again. So these are some of this. You can make some experiments how this works, but yeah, pretty useful things. And then there are logics commands that are pretty standard in programming. If you know something about programming, you already this will be pretty simple for you. But even if you don't, Robot Studio makes it so easy for us that it's easy to understand, I think. And first, the thing that I want to do is I want to move this program that we have made into a separate process here. So I don't want to delete it right now. I will just make a new process for it. So, and how you do that, you just go start a new line and say write pros, and then again it gives you here suggestions, and if you take this first one, it will just make the beginning of the process, but then, like you can see here, so there is a beginning and then there is an end. So if I delete this and try again, and then when you have this sign here, this means they are like prepared templates for code that is common to be used. So because when there is process, there is always end process, so that's why we have it here. And if we select that, you see we have process and end process. It's already ready. And also here it's we have already placeholders for where we have to put something if we want the process to work. So this is, we have to give it a name, and we can say p signals, and then we have to put code here, and let's just cut this and paste it here. And now let's make a new process and call this one p if, and now we can delete this, and now we're going to make an if statement. So you can tell the program that when it's going through the commands, if, for example, if a button is on, do something, and if it's not, just skip that and it will do the whatever is next. So we do that by, you can just start typing if, and then I guess again here you have suggestions. So if, it will just keep this if, but then you have if, else if, and if, and if and if. So if and if is if you only put one command. So if the button 1 is on, do something. But if and else if is if button 1 is on, do, for example, circle. If it's not on, so you say else if button 2 is on, do the ellipse. So maybe it sounds a bit complicated, but if I just show you now, you will see it's pretty self-explanatory. So we can say if digital input button 1, and now we have to say is 1, and here we have to use only this single equal sign, not like here where we use semicolon and equal sign, because this is just, so it's called boolean. It means it's either 1 or 0. So for that kind of commands you used this sign. So always in if you have to say with this one. And no, so if button 1 is 1, we can make p circles or circle. And else if, so if this one is not on, we can say d button 2 is 1, then we can say make ellipse and now else. So if neither of these are true, we can say make p line. Okay, let's try how this works. So let's say first we put a button, one button on. Oh, we have some problem. Oh yeah, the problem is that the main program is empty. So I made this process here and it's saved there, but what is being executed is only what is in the main program. So I have to put here p if, and now it should work. Yep, so now button 1 is on, so it went here. And because button 2 is off, it didn't do the ellipse, and also because this one is true, then it doesn't make else. Because so this else is only if both of these are not true. So for example, if I say both of those here are not true, it went to the line. And if button 2 is true, it makes the ellipse. And this else is actually not necessary. You can also delete it, and let's put set digital output after this, just so we know that something happens. So now I don't have else there, and I'm going to run this with both buttons off. You can see now, so it checked, this was not true, this was not true, so it skipped to the end of if, and now it set the light to 1. So whatever, if both of these are not true, it just jumps to end if and then proceeds with the code that is after it. But one thing, actually, I'll put the else back here, so just so you can see that there is an option for it. One thing that you should be careful about is that if you have both of these buttons on right now, it won't run both of these programs. So if I say play now, it should run only the circle. Yeah, and the light comes on, so it means the end of the process. And that's because it have a hierarchy. So if this first one is true, all of these get skipped. So, but if the first one is not true, it checks the next one and the next one and the next one. So you can put as many of these else ifs as you want. But as soon as it finds one that is true, it executes it and then it goes to the end of if. But if you want to have another one, like if you want to say if both of these are on, execute both of these commands, you have to go here, you have to make another if. So now I can say the button 2 is 1, which one do we have? Ellipse. So now both of these should run one after another. So first it checks here, it sees button 1 is on, so it goes to circle and then it jumps to end if, and then the next one is if button 1 is 1, then it jumps to makes the ellipse and then end if, and then the end of the process. But be careful with that, because now if I turn button 1 off, and run it. So first it comes here, it sees on this first if the ellipse is on, and then it goes to end if, and then again you have the another if with button 2 for ellipse, so it's going to run ellipse twice. So you can see it here. So there are many combinations of how you can do this, and yeah, you just have to try them and you will figure out what any of this means. And next we have while. So let's make a new process called while. The while loop is executing its code for as long as its condition is true. So if we say let's delete this while and end while, and now we have the condition, and we can say, for example, the button again is 1, and it's going to be executing p line, for example. And now in the main we have to change this p while, and let's see. So let's turn button 1 on. So this is working, and it's going to be working until we turn the button 1 off. So if I turn the button 1 off now, it finishes the what it was doing at the moment, and then it turns off. But we can also use not buttons, but we can use numeric variables here. For example, let's start a new while loop. So after end while we start a new one. We can make a variable called I, for example. So for as long as I is smaller as 5, execute p line. And right now, let's see if it creates it on its own. I think it won't work. Yeah, it doesn't work. So if you want to use a variable like this, you have to define it first. And let's go here in the beginning. And so these are constants, but we want variable, so write var, so variable, and now we have to say what type. Is going to give us some advice here. No. So we have to say what kind of variable we need. So we need numeric variable, so we just write num. And now we have to say what's the name of this variable, which is I. And now end this line. And one thing that we can make also here, there is a thing called rapid watch. We can put this here. So now we're going to here see what the value of this variable is. Oh yeah, and one more thing. Here now we can just leave it like this, or we can also define that, for example, I is 0, but it's not necessary. So we can also do this later. It doesn't have to be here. So, but let's leave it 0 right now, and let's run this. So I is 0. Oh, now actually we have to turn off the program pointer. So this is running while I is smaller as 5, and as you can see I is 0 and nothing is happening. So this is basically now going to be making a loop forever. So we have to turn it off manually. And the problem was that we didn't tell the program how it can change I. So if we want this to work, we have to say either increase the or decrease the value. So we can say here increase and I. So now increase is going to always put so when it comes here, it's going to say it's going to increase I by 1. So let's say see how that works. So 1 here, 2, 3, 4, and 5, and now it's 5. So this is smaller. I is now bigger as 5, or equal as 5 in this case. So the loop will end. And we can do the same if we would have this reversed. I smaller or bigger as 5, and let's put -5 so I don't have to change too much code. And we can say decrease here. So decrease does the same but in the opposite direction, so it decreases the size of I by 1. So and now if we run this, it goes back to 0 because of the previous that definition. I is 0, and now you can see here it's decreasing the value, and when it comes to -5 it stops. And there's one more way how you can do this. Maybe it's best if I make another while here and define another variable. J is 0. So while j is bigger as 5 or smaller as 5 actually, we can say line, and now we are going to manually define how j is changing. So j is j plus 2, for example. So it takes the value of the variable at that moment and adds 2 to it. And let's also do, so you can either drag it there or you can right click it and say add to watch. So we also have j here. So let's run this now. Oh, actually now it's still working for I, and yeah, it's not a problem, but I would like to show you something else. So if I don't want it to run this one right now, I can just add exclamation points in front of it. I think now it should already, no, oh, let's try, I'm not sure. I might have to add it to all of this. Yeah, I have to put it to all of this. So if you want to skip some code, you don't want to use it, but you don't want to delete it, you can just add these exclamation points in front of it. And let's see now, let's go back to rapid watch and restart this. So if you look here now, so 2, 4, and now it's going to go to 6, and 6 is more than 5, so it skips to the end. And again, there are many different combinations in how you can use this. So yeah, you have to just try it out. Next we have the for loop. So let's start a new process, and let's say b4 here, and for the code let's take the lines from the p line, and let's take only these middle lines, 9. We don't need the approach for this right now, and actually we have to make the for loop first. So for and end for, and let's put the lines in here. Now we have a little bit of a mess. Let's put a bit more back so it's easier to see. Okay, so and let's say a here from 1 to 5, and let's run this. And here I have a, I put it already in the rapid watch, and as you can see it's not changing when this is, oh actually I have to put p4 here, and let's run again. So you can see it's not changing, and this is because in this case here this variable here has a little bit of a special status. So it doesn't exist in this whole like full environment. So you can, and you could, as you noticed, we didn't define it like we defined here I and j. So we can use this that we have defined, or we can just make something new and use that. It doesn't really for loop doesn't care if it's been defined before or not. And also if you use this I or j, it won't really change their values. It will just stay it like it's in a separate kind of space. So I don't know, yeah, that's I guess what you have to remember, and if you want to know more you should read about it, because I don't know how to explain it right now. So when we are running this, it's just running back and forth, but I'm going to now show you another thing, offset, because the good thing about this here is you can use these values here in this code, and that is also the reason why we can change these numbers. So it's not that you would just say run a loop for this many times. You can say run from this number to the next number. So if we say here we're going to leave this first point as it is, and we're going to make an offset for the second point. So we can just say offs and then put this. So here now you have instructions. So you have offs, then you have robot target point, and then you have the numbers for x, y, and z. So I'm going to put this in this, and now we want x to stay 0, y to stay 0, and z to be 100. And if we run this, what is wrong now? Corner path failure. What is that? Oh, actually it worked. So now this offset moved this target 100 millimeters up in the z direction. But what we would like to do usually is not to, if we are using it in the for loop, not only move it to one point, but we want to have it changing. So we can say a times 100. So it's going to take whatever value it is at the moment and change the offset like that. So if we run this now, so it goes up, and every time it's going to be a different path. So you can see it here now. And we can also make this A change with a different step. So we can say step is 2. So now it's going to skip the first, and it makes only these 3 lines. So because it's going up by 2. But let's put it back to 1 right now. And what maybe you noticed that it's not making it's not making a path on this first one, and maybe you want that, and if you want that, you have to put the beginning of the for loop from 0, and then if you still want to have 5 lines, you have to go to 4. So this is from 0 to 4 is now 5. So if we start now the first one is going to go here, next one, and so on. So you can put any kind of numbers here. It all depends what you want and what you need. And now we're going to use that to make this robot weld on all of these edges here, for example. And let's make a new process for that. Process, and let's call it pattern. And let's now copy all of these. And actually we have to first make a for loop, 4 and 4, and let's cut these and paste them here. Oh, why did they change? Well, I think it should still work, doesn't matter if the colors aren't correct. And let's say this is A, and because we want to make the first one, and how many do we have? 1, 2, 3, 4, 5. So we have 5. So from 0 to 4, and now we need the distances between these blocks. And if you don't know them already, if you have a technical drawing of what you are doing, you might know it. But if you want to measure it, you can go here to modeling, and you have point to point. This is how to measure, and then now you can just say here snap object, so it will be snapping, and we can just take so we have 80 millimeters is between each of these beginnings. And let's turn this off and prep it. So we have to move 80 millimeters in Y direction from one block to the next block. So we're going to make offsets here. So 0 for X, 80 for Y, and 0 for Z. And I'm going to just copy this, it's going to be faster. like this, and then it was 20, 30, 40. And let's make this first one a bit faster. Let's put 3000 for example, and let's see how this goes. So actually I have to change here key pattern. I can oh, key pattern now is shown. Let's see how this goes now. Oh, actually, oh yeah, I made a mistake. So I forgot to put a times 80 here. So a times 80. So first, in the beginning, a is 0, so the offset is going to be 0 for the first round, and then 1 and 2 and so on. So let's see now. Okay, so now you can see it's welding on all of this. And if we want now to move on this side, we have to make another for loop. So let's go here and say 4 and 4, and now we have to move this for loop inside this for loop. Let's make indentations just so it's easier to see. Oh, too many. And like this, and let's call this one B. And so this is, we have only 2 instances, so we can go from 0 to 1. And now we go in X direction. So in and the distance, so another way how to measure distance, a faster way, is you have here shortcut, and again we have to select this one, and let's put it in 330. So X is B times 330. And let's see how this goes. And now it should jump to this one. Yep. So this way it's very easy to, oh, here it had some problem. Okay, I guess it can't reach that point, but well, we can neglect that. It's not so important right now, so we can, you see that it works, and I think that's the most important, and then you can try on your own to improve this. So like this you can automate a lot of your programming, or you can make your programming much more efficient, because so now we have here how many lines, 7 lines. If we would say want to make all of this by hand, it would take many lines, but this makes it very fast and easy. So it's something to keep in mind when you are making programs. So now the last thing that I want to talk about now is, before I was telling you that you have to be careful about the difference between the program pointer and the robot pointer, and we're going to make a new process to demonstrate this. we can call it delay, and let's take the circle code here. And now the last, so here we have the last one. It's going to be a bit easier to see if we make an offset here, so it's going to be a bit longer. So we need an offset in Z direction, so 0, 0, and oh wait, what am I pressing now? Zero, 0, and I don't know, let's try 500 if it's going to work. And then after this, let's say set digital output light. And oh, again, I forgot to change the main. Delay. And run. So now if we follow the light, so it turned on already. So it turned on when we were somewhere here. And so how we can change this? We have to put another code, another line of code in between here. So we can say wait, and here we have an option wait rob. So it means wait for the robot. So wait rob, and then we have an option here in pause, so in position, or 0 speed is another option. So it will, if you say wait in pause, it's going to be waiting until the robot finishes its previous command or movement. So if we say in pause here and run this, oh, I have to turn off, and now in the end the light came on. And this is important because if you have some kind of system with outputs and inputs, if you send this output too fast, some other process is going to start, and then there's a good chance that something is going to crash. And I can show you that by making some points, also some new targets. And so here we have these targets defined as constants, but we can also define them as variables. So we can say variable RobTarg, and now we can say what's the name of this target. So we can let's start with T, and delay 1. And again, we don't have to define these numbers right now here. We can just say that this exists. And let's make another one. The delay 1, delay 2. And right now here actually I'm noticing I didn't put the right beginning to these variables, so you should always start it with n to make it more clear. So I'll leave it like this now so I don't mess up the code, but keep that in mind. So numeric variables should start with n. And now we're going to have a new command, and that is, so we can say t delay is CRobT. So CRobT saves the current position of the robot, but we still have to define the tool and the work object that we want to use for it. So first we can say tool is t-weldgun, and then we have work object is what do we have, training piece. And let's add this to rapid watch, and then let's put the other one here, delay 2, and also add this one to rapid watch. And now if we run this, so now this is 0 because it's not defined, and now the first one gets defined, and now then the second one also gets defined, and you can see that they have different numbers. And if we want to see how much different, we can just go back to that point. So we can, let's say, make another joint here, joint move, and as the target, let's say t delay 1. And now let's run this. So it comes up, and now it's going back. So you can see the signal went forward already here. So if you would have some kind of output here saying, okay, I'm ready, and then something else will start moving, there is a good chance of something, like I said before, crashing into each other. So this is really important that you keep this in mind. This wait robot in position is really useful command that I think you will need a lot of times. This is all for now, and I'm going to save this and make a pack and go file, and I'm going to share it with you, so then you can if you have some problems, you can check out my code and yeah, see what is wrong if you get stuck somewhere. And I recommend you try to make a little bit more complicated system with all of these different commands that we have done today, so you get a better grasp of how it works. And see you in the next one.